Hello and welcome to our Mathcast on parallel lines and transversals. Our goal is to help you better understand the concepts at hand when you need it and at your own pace. We hope you enjoy this Mathcast on parallel lines and transversals. Well, what are parallel lines and transversals? Parallel lines are two lines in a plane that never meet. Here's an example of two parallel lines. Perpendicular lines are two lines that intersect to make a 90-degree angle. Here is an example of two lines that make a perpendicular angle. A transversal is a line that intersects any two or more other lines. Here is an example of a transversal line that intersects two parallel lines. Thus, the name parallel lines and transversals. In this slide, with parallel lines and a transversal, we can find congruent angles. Now, if two lines are intersected by a transversal, which is this blue line right here, and any of the angle parts are congruent, the lines are parallel. We can use that to help us find congruent angles. So if you know that the lines are parallel, then pairs of angles are congruent. So let's circle the pairs of angles that are congruent with each other. Angle 1 is congruent with angle 4. Angle 2 is congruent with angle 3. Angle 5 is congruent with angle 8. And angle 6 is congruent with angle 7. Now, since these lines are parallel, that means that angles 1 and 4 are congruent with angles 5 and 8, and angles 2 and 3 are congruent with angles 5 and 6. Usually you can tell which angles are congruent with each other. Now let's put what we learned into a simple example. So let's try to find all of the angles that are congruent to angle 1, and all the angles are congruent to angle 2. We already went over which angles are congruent, but it's good to practice and to break up the congruent angles into pairs. So angles 1 and 4 are pairs, angles 2 and 3 are pairs, and angles 5 and 8 are pairs, and angles 6 and 7 are pairs. So if angles 1 and 4 are congruent with angles 5 and 8, that means that angles 4, 5, and 8 are congruent with angle 1. That also means that angles 2, 3, 6, and 7 are congruent with each other. So the angles that are congruent with each other to 2 are 3, 6, and 7. This example is a little more difficult. In this example, I will demonstrate how with one angle measure we can find the rest of the angle measures with what we have already learned. First, to keep track of what angles are congruent, let's write out all the angles' names and signify the ones that are congruent with each other. Bam! So let's circle all the angles that are congruent with 1 and underline all the angles that are congruent with angle 2. But as you will see later, we can get all the answers without knowing which angles are congruent. So as you can see, there is an angle given to us, which is angle 1. To find angle 2, you must subtract 118 from 180. Well, it is 180 degrees because the degrees on a straight line is 180 degrees. Or as you might have learned from another Mathcast, is that it can also be called a straight angle. So now 180 degrees minus 118 equals 62 degrees. That means angle 2 equals 62 degrees. Now since we know these two angles, we can find out the rest of the angle measures because we know what angles they are congruent with. But even if we did not assume that, we could figure out the rest of the angle measures with what we did to find angle 2. But this time we can use it to find angle 3. This time we're going to go across the transversal line. So let's subtract 62 from 180 to get 118. Wow, would you look at that? The same as angle 1. And we would get 62 for angle 3 because we subtract 18 from 180. Now we can put the degrees of each angle to make our answer final. Excuse me if I have made a mistake. We use angle 2 to find angle 4, and we use angle 4 to find angle 3. Sometimes a teacher, or whatever you're working on, might ask you to find the alternate interior or alternate exterior angles. What they mean by that is quite simple. Alternate interior angles are the angles that are inside this imaginary box that I am drawing. And they have the same angle measure, so this means they are congruent. So both of these would be alternate interior angles, and both of these would be alternate interior angles. Alternate exterior angles are the same thing as alternate interior angles, except the angles are outside of this box. So these two are alternate exterior angles, and these two are alternate exterior angles. You might also be asked how to explain things. In this case, we have to demonstrate why we cannot draw a figure. Line A is parallel to line B. So in this word problem, it would be a good idea to draw a figure to help you better understand how to answer the question. So let's draw two parallel lines and label them A and B. Now, line C is perpendicular to line B. So draw a straight line down through line A and B and label it C because perpendicular means 90 degrees. Line C forms a 60-degree angle with line A. Why is this figure impossible to draw? Okay, now look at your figure. Think why it cannot be 60 degrees. It's because perpendicular equals 90 degrees. So in your answer, you have to say something like, it cannot be 60 degrees because perpendicular means 90 degrees. So all angles are 90 degrees. Thank you for listening to this Mathcast on perpendicular lines and transversals. Please feel free to listen and learn from other Mathcasts on this channel.